Welcome everybody to Njord's live event on wind-assisted propulsion systems. My name is Frederik Pind and I'm the Managing Director of Njord. Njord is a green technology company originally ideated between Cargill, Mitsui and Maersk Tankers. And in Njord we work with ship owners and charters accelerating their green transition by assessing, designing and installing combined packages of energy efficiency technologies. Njord delivers both a technical and commercial analysis, and we operate independently across technologies and suppliers. And with a growing portfolio of more than 30 technologies we work with, and one of those is obviously wind-assisted propulsion systems. There are now more than 30 wind installations completed in shipping, and with the outlook of surpassing 50 installations in beginning of 2024. And there are more than 25 suppliers of wind-assisted propulsion systems in the market right now. There is a popular saying, which is wind is the free fuel. So there's good reason behind the high level of interest and number of increasing technology variations and actual installations done in shipping. However, if it's free, and we like things that are free in shipping, but if it's free and it has been around for years, tested, piloted, proven, then why is the adoption not much more aggressive? Some of the typical barriers around wind-assisted propulsion that we in Njord hear from owners and charters when we help them assess, design and deploy combined technologies are some of these. Firstly, we see that there is a broad and complex supply and solution landscape out there. So what to go for and who to go for. Safeguarding the fuel savings in different weather conditions is not possible. That's at least an assumption we hear. The capex for deploying is too high and the business case is simply not there. And it takes energy to create energy. So wind systems comes with energy constraints, how to mitigate that. Installations are very complex, or can be, and the general landscape of energy efficiency technologies is very broad. Is wind the right thing for our vessels, or should we consider something else? However, there is good opportunity in improving your financial performance while reducing carbon emissions through wind technology. And in our live event today, we have invited 5 industry experts to our panel to talk to us and talk us through the perceived barriers and help us clarify the current landscape of wind in shipping. As an audience, you are able to post questions anytime during the event. So please, just go in and comment. We will try to respond to as many as possible as we run through. So don't wait until the end to post your question. If you already now have specific questions you'd like to have answers today, then feel free to start typing. With that, then it gives me a lot of pleasure to introduce to you the 5 panelists that we have with us today. And I will start with Lauren. Lauren is the head of wind wings at Bar Technologies. Lauren was originally a structural engineer in the yachting industry. Then from a founding member of Bar Tech, she became the head of engineering. Lauren has led the design and development of wind wings since its inception 4 years ago, from concept sketches through to installation and sea trials with the first 2 wind wings vessels in operation. Welcome to the panel, Lauren. Then we have Cristina. Cristina is the Chief Operations Officer and co-founder of Bound for Blue. She has a Master of Science in Aeronautical Engineering and an Executive MBA from IESE Business School. Cristina has participated in more than 10 national and European projects, being the inventor of more than 5 patents in the field of wind-assisted propulsion systems and its various applications. Welcome to the panel, Cristina. Then we have Jukka. Jukka is the Chief Customer Operations Officer at Norsepower. Prior to joining Norsepower in 2016, Jukka worked in management positions of sales, service, and delivery projects functions in both maritime and wind power businesses. Welcome to the panel, Jukka. Then we have Jean-Charles. Jean-Charles is the Sales and Business Development Manager for Oceanbird. He is a merchant Navy officer by education with an experience of 10 years at sea, working on various types of vessels as bridge and engine officer. He stopped sailing in 2014 and held different sales and business development positions since, focusing on energy efficiency solutions for the shipping industry. And last but not least, we have Sten Jacobsen, who is the Technical Director of Njord. Sten, who's a bit of a shipping industry veteran, has more than 30 years of experience with Maersk, closing in on 40 years, Sten. And he has been responsible for driving results through innovation in areas of fuel efficiencies, new building supervisions, and retrofits, among others. His key roles have included head of fleet technology, head of cost leadership and fuel optimization, while also having sailed as chief engineer on all types of Maersk oil and chemical tankers. So, welcome to the panel, Sten, and a big welcome to everyone. And thank you very much for being on the panel. So with that said, we'll dive straight into it. And we'll start with the first question of getting to know the different technologies that you represent a bit better. So I'll start by asking you, Lauren, in brief terms, can you tell us about the specific technology and how it works?
Yep, absolutely. So this is our 37.5 meter wind wing. 37.5 is the aerofoil size by 20 meters, so 750 meters of area producing thrust. What's unique about it is it consists of 3 elements, so 3 unique aerofoil shapes that work together and adjust so that they can change the shape for a wide range of wind angles of attack and wind speeds, producing excellent performance for a range of environments.
Thank you very much, Lauren. And great to see some visuals of it here. Super interesting. Let's jump to Cristina and hear a bit about the technology at Bound for Blue.
At Bound for Blue, we offer a suction sail, which we've named E-sail. And a suction sail is a type of wind propulsion system that is pretty similar to an airplane wing, but in this case, we use much thicker profiles. And then we also have this band that you can see here, which is gray at my back, which is a porous perforated area. And what we do is suck in the air from the outside to the inside of the profile to attach the airflow. And then we release it from the top, thanks to a fan and a normal ventilator that is located at the upper part of the system. And by doing so, we are able to achieve very high lift device, which translates into much higher fuel savings and emission savings. So I've left you here a QR code in case you need much more information about the technology.
Thanks, Cristina. Super interesting to see. Jukka, let's jump to Norsepower.
Yes, Norsepower's rotor sail is a modernized Flettner rotor. It creates the lift force by spinning in wind, and the spinning is made happen with an electric motor, which is located inside the rotor sail, connected directly to the rotor, so no gears are involved. And when the wind meets the rotating surface of the rotor, then a lift force is created with the Magnus effect, providing the thrust force to push the ship forward.
Thank you very much for the introduction, Jukka. Very interesting stuff. And then last but not least, Jean-Charles, let's jump to Oceanbird.
Yeah, first a few words about Oceanbird. We are an independently operated company, but relying on 2 strong mother companies, which are Alfa Laval and Wallenius, and we are super proud of it. We are currently developing the Oceanbird 560, which is a rigid wing sails made of high-strength carbon steel for the structure and glass fiber for the airfoil. The height is 40 meters and the width 14, which make a total surface of 560 square meters. The wing can freely rotate 360 degrees and adjusting to the optimal angle of attack. It also consists of 2 segments, the main sails on the front and the flap on the back. And by adjusting the deflection angle between the main and the flap, we can create a curve in the design of, or in the shape of the wing, and also called a camber. So by this free rotation, 360 degrees, and the possibility to have this camber, we can set the sails to give the optimal propulsive effect to the vessel. Last, when the wind is going too strong, or when we are passing bridge or entering at board, we fold the flap on the main, and before we tilt it on the deck to an horizontal position parallel to the deck. That's basically the short explanation about our system.
Thank you very much, Jean-Charles, and thanks for all of you to giving a short introduction. And again, I encourage the audience, in case you have questions to either of these, you are welcome to ask direct questions to any of the panelists or questions in general, and then we'll try to cater for that as we run through. I'll stay with you, Jean-Charles, because then what the next question will be is around implementation. So wind technology has actually been around for a long time, but it has resurfaced again. And then I know that the different technologies are at different stages of implementation. I would love to hear from your side, Jean-Charles, on Oceanbird. Where are you when it comes to implementation of these technologies?
Yeah, thank you for giving me this opportunity. So we are starting in a chronological way. So at the end of the year, we are starting building our scale 1 land-based prototype. So that's going to be located in the west part of Sweden. So we are starting building, and while we are building it, we are going to verify a sub-function and sub-component of the system. We expect to have the land-based prototype erected towards mid of 2024. In parallel, we have our onboard prototype. It's going to be installed on a Vale New Zealand vessel called Tirana. The vessel is expecting for 5 years dry dock in China mid of 2024, where we are going to make the structural reinforcements and installing the foundation. While the vessel is going to sail back in Europe towards the end of 2024, we will install the wing on board. And last but not least, actually, we have also the ambition to contribute to the wind propulsion with more wings installed on board. And if you see on this corner of my picture, it's a wind-propelled vessel from Vale New Zealand that is expected to be on water in 2027. So land-based prototype starting this year, scale 1, onboard prototype next year, and finally the sailing vessel a little bit further away in the timeline.
Super. Thanks a lot, Jean-Charles. Looking very much forward to see some pictures and some insights from mid-2024 on the prototype out there sailing. Let's jump to Bound for Blue. Cristina, tell us about where are we in terms of implementation of your solution here?
We've already installed 4 units on 3 ships, 2 general cargo ships and a fishing vessel, a longliner. We have more than 4 installation projects ongoing in different segments, ro-ro, tankers and bulkers, with more than 15 sails already in production, units ranging from 17 meters high to 26 meter high, although we also have in our portfolio sails that range up to 36 meter high, and working with some companies with whom some of you might probably know, like Louis Dreyfus Armateur, Marubeni Corporation, Eatwell, or Amazo Shipping.
Okay, thanks a lot. And 2 installations on the water. We will soon talk about the effect that we've seen, but we'll save that for now. But I'm definitely going to come back to that, Cristina. Thanks a lot. Lauren from Bartek, where are you on implementation?
Yeah, so it's been a really exciting couple of months for Bartek. We've launched our first wind wings in the past couple of months. So we have 2 vessels on the water now, the first fitted with 2 wind wings and the second fitted with 4. And they have completed sea trials both. They're on all of their first or second journeys now. So we're getting first results back from our fuel savings, which is really exciting.
Super. Thanks a lot, Lauren. And then to one of the ones that I'm, I would say, most familiar with, because that's at least something that Maersk Tankers has also been involved in. But Jukka, jumping to Norsepower, tell us about implementation from your side, please.
Yes, thank you. First rotor sail from Norsepower was installed in 2014, so we're soon coming to the 10-year anniversary on the ro-ro ship Estraden, where 2 units are still in operation and in very good operation and efficiency. So far, we have installed 16 units, which are sailing on 7 vessels. And the next 12 months will be a very busy time. Market has become really active and demand is increasing. So we are installing on a further 10 ships, a total of 14 units.
What have you seen when having implemented these different solutions in terms of savings and also return on investment? And let's stay with you, Jukka, on Norsepower. What have the findings been?
Yes, so quite a variety of performance, of course, because of the nature of wind. So wind conditions are the main defining parameter actually for the performance of fuel saving emission reduction. And what we see typically is savings between 5 to 25%, depending, in addition to the wind condition, also of the configuration, how many units can be installed on deck, what is the time at sea for the ship. So the more you're sailing, the more you can save, applies for any kind of wind propulsion system. So it's really a wide variety. On the best performing ship, the SC Connector sailing on the North Sea, there are days when they can save 70% of fuel because of the optimal wind conditions, but also very high capacity of the sail installation.
Okay, thanks a lot. Those are some high figures, Jukka, very interesting. Then I'll actually jump to Sten. Sten, you were part of the pilot of putting rotor cells from Norsepower on Maersk Tankers, the Maersk Pelican, back in the days. Tell us a bit about that experience and the savings that you saw from that test.
Yeah, so that was a very interesting project where we set out to confirm not only how much could a vessel save over a year, but also confirming the polar plot, the theoretical model of what can be achieved when the wind is blowing from a certain direction at a certain speed. What is then expected? What kind of thrust can be expected? And we had an expectation of 10% savings over a year, and we ended up on 8.2%. But that's actually a really good result because we were idling with the vessel for prolonged periods and definitely did not trade after the wind. So as Jukka mentioned before, we had some legs where we were 20+% savings on that leg. And then, of course, we had periods of low wind and less savings. But overall, impressed with the functionality of the system, but also the gains that we got. The 8.2% was savings compared to the total consumption of the vessel, including idle and port time and so on. So quite a well performed test. And maybe more importantly for us was the polar plot, the theoretical model, because this proved to us that we can calculate the efficiency of wind installation spaces, the expected voyage and global wind average in these areas. So it was an important tool for us for the next steps.
Thanks, Sten, and thanks also to it's a good combination of hearing both from your side, Jukka, but then also from in this case, Sten actually being a customer of the products being deployed. Cristina, I'm super curious. You mentioned 2 installations done already. Your view on the results seen, both in terms of the savings achieved, but also the return on investment, so the actual business case.
So in reality, it's 3 installations, and I'd like to talk about the last installation, which was done this summer in the Ems Traveller, which is a general cargo ship, and we installed 2 sails of 17 meters high. So there we expect to achieve between 10 and 15% fuel savings, which at the end of the day, this will depend highly on the final trades and on the operations of the ship. But just to give a glimpse of some numbers, on one of the routes we did in July, just when we finished the installation, we did an on-off test at constant RPMs. So on one side, we saw an increase of 1.2 knots due to the thrust of the sail itself. And then on the other side, we also saw a 6 to 7% of fuel consumption reduction due to the improvement of the propeller efficiency. But if in this case we would have kept constant speed, not constant RPMs, the sail would have delivered on that route around 30% of fuel savings. But at the end of the day, it really depends on the route. So on average, 10 to 15. We're right now recollecting data, and this data will be validated by a third party. In this case, it will be Lloyd's register and will be made available for the industry as soon as possible. And also with respect to the payback for this ship, we expect a payback below 5 years.
Okay, 5 years and up to 30%. Very interesting figures. So thank you very much for sharing here, Cristina. We actually have a very interesting question from the audience that we'll just post up here on the page here. So the question here comes: would appreciate if panelists can highlight any restrictions on implementation for vessel size, especially for bigger vessels in tanker and bulk carriers, i.e. are they implementable for VLCCs and Capesize bulk, etc.? So I'll actually pass on that question to Lauren, because you've just recently looked at implementation, right? And your first sales are out there now. So Lauren, any reflections from your side on this question?
Yeah, absolutely. I mean, there's a strong focus when developing a wind technology to make sure that it's applicable to a wide range of vessels and optimized for that wide range. So the wind wings you can put 1 on the bow, on the forecastle of a Handymax. You can put 4 on a Newcastle Max, like our second installation, and all the way up to VLOCs, no problem. You can put several on the decks of those. And The good thing about our technology, and one thing we focused on, is the lack of interaction between those. So no knockdown on effects. The more wings you add, the more performance you gain. They have very little interference with each other. So that allows us to scale up and down for vessel size as well, really easily.
Thanks for sharing your thoughts, Lauren. I think Jean-Charles, I'll actually pose the same question to you. Reflection from Oceanbird.
So no limitation in terms of type of vessel and size of vessel. Obviously, I mean, different size of wind power unit will match different size of vessel. But when it comes to different segments, I think we are still studying a lot on different, and we are learning on different segments, but we don't see any limitation as such. Obviously, each segment will have its own specificity. I can mention, I mean, hazardous area and EX requirement maybe on tankers, and the footprint of the pedestal for bulk area, for the space between hatch covers and stuff like that. I will not enter into the details, but I think we should not get stuck into this foreseen limitation, because we are going to find some way to twist around them and to propose the suitable product or the suitable solution for each individual segment of the shipping industry.
Thank you, Jean-Charles. Very interesting. I'll actually pitch the question back to you, Steen, both from a, you could say, a customer perspective when the Maersk Pelican case was relevant, but also from the work that you do today in Njord when you help owners assess what's the right thing to do. Then what are the things, you could say, restrictions, limitations that you are looking at when you assess the different solutions for the different vessels?
Yeah, I would say the starting point is where is the vessel trading? Will there be sufficient wind to justify the investment for wind-assisted propulsion? But that's kind of the obvious part. If we look at physical limitations from a more pragmatic angle, also what we experienced during the planning for the Maersk Pelican, you need to understand and document, you know, stability. Will there be any issues? What about strength on the deck around the foundation? What about line of sight regulations for navigational purposes? Do we need exemptions? Can we get them? And how is that going to happen? You need to understand windage numbers and stuff like this. All this is, I would say, it's not really limitations, but it is small obstacles that have to be addressed and documented and get a sign off from class and everyone. I think it's a more or less standard approach today to go through these things. So there can be challenges, but they can normally also be overcome.
Okay, thanks a lot, Steen. Then I want to jump into the energy constraints. That's one of the barriers that we at least typically hear, and so this is also one of the things to be aware of. So the typical reflection is that wind power actually requires energy to produce energy. And I'll start with you, Jukka, on your specific solution and how you see the energy constraints or the requirements related to your product.
Right, yes, that's definitely true. The auxiliary power consumption of the rotor sail is something to consider in the very early stage of planning the installation. Depending on the model, we have 5 standardized models. So the smallest one, average consumption is typically in the range of 15 kilowatts per unit. And the largest model, which is 35 meters in height, average consumption typically 50 kilowatts. So this is the amount of electrical power for average consumption. However, the acceleration of the RPM, which is the way that control system adjusts the performance of the rotor sail, is adjusting the RPM. The consumption is momentarily about 3 times this value. So it's up to 150 kilowatts per unit on the largest one. And these kind of figures start to be already of the magnitude where, especially retrofit projects, you need to pay attention to available auxiliary power, and if necessary, the power ramp ups can be adjusted, power limitations can be implemented to make sure that the power plant is working also optimally, efficiency wise.
Okay, thank you. So some power offtake here. I'm curious to hear, so if we switch from rotors to sails, Jean-Charles, from your perspective in terms of energy constraints of your solution, can you give us the insights here?
Yeah, I think we are highlighting that quite a lot when it comes to wind sails, but it's a bit close to be a passive system, meaning that the electrical consumption is expected to be very limited. So obviously we are going to have some peak consumption while tilting up the wing, putting in a vertical position, but that will be for a very short period of time. And our expectation for Oceanbird is to be in the range of 50 kilowatt for this peak consumption. During normal operation, I think it's going to be a very slow and not frequent movement of the wing. Obviously, we have to adjust to the different wind spin and direction, but the expectation is to be around 5 to 10 kilowatt of self-consumption of the system, so very limited. Again, for us, it has to be confirmed during sea trial and test, but we are pretty confident that we will be in this range of figures that I highlighted today.
Great, thanks a lot. So so not maybe to the same extent, but still some kind of power offtake required here. Sten, I'm curious to know, because now we move into the field of combining technologies. Is there any ways or any good practices around then adjusting or approaching that kind of energy constraints when looking at wind assisted propulsion systems here?
Yeah, sure. Sorry. When we are looking at these vessels, we try first and foremost to address the power consumption on board and see where can we optimize with anything from LED lights, variable frequency drives, etc., to lower the energy demand on board from the generators, and that way free up more power. So more in the Norsepower case, rotor sails, and we can match how many rotor sails can we fit basis the power available. If we do want more rotors than that, we can look at power take-off systems that can be retrofitted. That complicates the business case somewhat, but with the prices of fuel today, expected prices on the more greener fuels, the ETS and so on, then there's actually a business case in itself for power takeoff on some vessels. So it's a very holistic combined investigation that we do, so we can match up what is actually feasible, what's the best combination of technologies. But yeah.
Thanks a lot, Sten. Super interesting here. So the combination of things, and I will actually jump to that. So we'll have another question from the crowd coming up here as well, and maybe it's a bit of a leading question as well, but we'll take it anyway. So question for all panelists. Dependent on wind force and direction, are there any particular routes where this would be the most suited basis weather data for the last few years? I think I'll jump to Lauren from Bar Technologies on your reflections on this one here.
Yeah, I mean, of course, there are certain routes that are favorable. So the traditional sailing routes across transatlantic routes have very favorable wind conditions, and there are other routes that have lighter wind conditions. So our fuel savings are calculated we average them across global routes, and we're still getting kind of 1.5 tons of fuel saving per wing per day. But on good routes, that could be up at 8-9 tons per day per wing, and we've already validated some of that in our sea trials in our first voyages. So we've seen performance in only 25 knots of breeze, so they produce thrust up to 40 knots of breeze, and in 25 knots we were seeing a reduction of 11 to 18 tons of fuel per day. So yes, it very much depends on routes, and you need a case-by-case basis to look at your exact payback period and return for your vessel and its typical routes. But certainly there are savings to be made across the range, and even averaged across favorable and less favorable routes, there's still a business case.
I was hoping, Cristina, to have the same question answered from your side, basically. Could you have a reflection on your side also combining, looking at winds into different routes, and what are the good practices there?
So, I mean, it's pretty similar to the rest of technologies in the sense that the North Atlantic, North Pacific routes are very suitable. The Baltics are very good routes. Other ones, like maybe Mediterranean, would not deliver such good payback for wind propulsion. But at the end of the day, it really depends on the operational side. So I would suggest the owners to have a look at it case by case in that sense.
Yeah, and that's the case by case look, right? And I think, Sten, also from your perspective, right? Because I know in Njord there's been a number of projects where we then looked at, does it even make sense, and what are the things to be aware of here when you start looking at wind propulsion and the trading routes of the vessel? How do you figure out whether this is a good match?
Well, basically, you engage with the suppliers and do simulations on the actual routes with their simulation tools on how much power will you gain from winds from various directions, and you have a pretty good estimate of what you can expect. And that was, one of the interesting parts I explained about the Maersk Pelican case. Having a confirmed theoretical basis is super important to make that business decision easier. And then you can scale up and down with number of wings or rotors on board a specific vessel. Yeah.
I know that from a partnership at least announced earlier, Norsepower has worked quite closely with a weather routing company. Can you tell us a bit about the findings you've had and how that collaboration has enabled your technology even more?
Definitely, and that was something I was actually going to bring in the next opportunity. The voyage optimization, we work together with a company called NAPA, and we are able to work with any weather or route optimization company to implement the benefits. We've seen a potential for improving the fuel saving performance, typically around 20 to 60%. In some cases, even 100% improvement when you can really plan your voyage with the mindset of maximizing the benefit of the sails. Of course, always keeping the time of arrival as required, but this means that you would no longer take the shortest route, but you will follow the guidance of the optimized route, which then considers the performance of the sails in addition to all the other parameters that the systems already consider. So it's really a great help for the captain and sailing decisions for navigation.
Okay, great. Thanks for sharing that, Jukka. Then I want to move on, and again, my assumption is we have quite a number of potential either ship owners or at least people who represent different ship owners on the call today. And one of the questions we at least get is it even suitable for me? So we have different sizes of vessels, we have different types, different trading routes. There might be some constraints around that. So what are the different considerations as a ship owner they should think about before reaching out and before considering whether wind is the right option for them? Jean-Charles, I think I'll start with you and Oceanbird.
But I think they should simply knock at our door. I mean, we are also in the phase when we want to prove and to make our technology standard on the industry. So what we do when typically ship owners are coming to us, we are looking at drawings of the vessel, we look at feasibility, and we are building a case in performance evaluation, the all transparency according to the trading area, the type of vessel, with all technical and economical parameters agreed and shared transparently. So I think there is no, the consideration will come during the discussion. So there is no, things to consider really before coming to us. And again, we are usually making this evaluation in terms of performance and integration and both in collaboration and all transparency with the different people we are speaking with. So I think it's when we talk about the performance as well, we have highlighted some favorable and non-favorable routes. Typically, we are going to give the performance related to the specific vessel on the specific route, whether it's favorable or not. So I think it was the effort of the taking the opportunity to talk with one of us and to get into this topic. I think we can offer good support.
Okay, so no limitations, just knock on the door. Okay, I like that. Thanks, Jean-Charles. Then Lauren, same question on Bartek.
Yeah, it's a very similar answer that limitations in terms of the cost and the payback is very much a case-by-case basis. And like Jean-Charles says, you have to agree the parameters of that. What are your foundations for making those calculations? And also then the routes that your vessel will be trading influences it so significantly. the type of vessel that you have. So as mentioned earlier, if you've got a bulk carrier and you need the wings to be able, or wind propulsion device to be able to fold out of the way so it doesn't obstruct cargo operations, that's important. Any bridges to go under, that you have height restrictions, and also your utilization, so the amount of time that you're actually at sea sailing. Let's not forget the lost time when you're in port conducting port operations. So for some vessel types, that will also be significant on their usage case.
Yes, and I think just picking up on that, because that's actually quite relevant, and we also see that in the chat that we have a question here. Have you ever faced any issues in terms of port restrictions? But we also have a question which is more on the technology front or on the safety front on vibration. So maybe on both of those points, Cristina, from your side on Bound for Blue, what has been your considerations and findings around those topics?
So today, at least with the clients we're working with, and after consulting also with major ports around the world, we haven't had any constraint. The system, because it's a very high lift device, it's quite compact, so it's able to generate a lot amount of thrust being very small size. So basically, we're not having restrictions on that side. And then on the vibration side, because the mode of operation works pretty similar to a wing sail, it's not rotating the system. The only part that's rotating is the fan at the top. We don't have vibrations and neither noise. So we haven't had any constraint on that side.
Okay, thanks. Jukka from Norsepower, same reflection for you?
Yes, the ports and terminals where ships are visiting, of course, they have questions, which it's a good idea for the ship owner to check the most commonly visited ports, that if they are not familiar with the type of sail products that they are aware of what the ship will be equipped with. We have neither found out any restrictions so far, but it has been a topic for our customers before they make the final decision, that they check the ports to make sure that there are no showstoppers for the operation of the vessel. So definitely an important question. Then to the vibration aspect. So of course, rotor sail with the rotating mass of the largest model is more than 10 tons. So naturally, it has to be very well balanced to avoid vibrations. Of course, the vibrations from the ship's operation also influence the sail. And these are, of course, something that we can control by then making the foundation structure and the steel structures strong enough and considering the vibration characteristics. So it's an aspect to consider during design, and our vibration sensors on the rotor sail, of course, take care that should there be any abnormal vibration, then the system is safe by shutting down and finding out what is the issue.
Thanks a lot for sharing that, Jukka. And then I think there's a lot of things to consider here, and a lot of things to evaluate before diving into it. And I think what is then also quite interesting, and we also hear that from your side, is then getting to installation. How to get there? Does it require dry dock? How cumbersome is it? Is it something that's going to hamper time in the dry dock? And I'm actually quite curious to hear, Steen, from your side, maybe some experiences from the Maersk Pelican, and also how some of those learnings can benefit the rider industry going forward.
Well, the Maersk Pelican had the foundations installed at a dock, and there the most intrusive part of that work was cutting into the ballast tanks to create some extra strength for the foundation, and the rest of the foundation was fitted under structure on top of the main deck. So it was, that is dock work. It's not necessarily dry dock work, and time-wise, it would not affect the docking period as such. It can be done in a normal dry docking schedule. In our case, we installed the rotors later in Rotterdam, so that is also a combination that I would expect is not uncommon to first make the integration to the vessel and then later match the sails.
Mm-hmm. Okay. Good point. So it's a bit of a model approach, basically one by one, but starting with the foundation and then the actual rotors.
I'm kind of foreseeing that both on retrofit, but predominantly new buildings, it would be wise for ship owners to pre-plan potential sales, so there is deck space and strength in the deck and integration available, and then they can always, if the vessel is going to trade in favorable areas, they can install the sales there.
Yeah, super interesting. And so that was a bit of an experience, at least from the rotor side. Cristina from Bound for Blue, installation process and some good practices that you have here. Could you elaborate a bit on that?
So on the installations we've already done, we followed like two approaches, either making the reinforcement and installing the sail, or all of it together at the shipyard at a normal maintenance activities. And then on the other side, we also have the approach of doing the reinforcement at the shipyard and then laterwards at the port call installing the sails. So this was the case for the last installation we did in July, and it took us less than 4 hours to install the two systems on the port. And it was the first time it was done in that port and for our technology. So we are very confident that we can reduce that, so to speed up the installation and the implementation of this type of solutions.
Did you say 4 hours?
Yeah, 4 hours.
Impressive. Okay, well done. Yeah, okay. And you want to speed that up further. That's very interesting.
2 hours maximum.
I like that. Very good. Thanks, Cristina. So then what I'll jump to next is a question also we have here in the chat, which was also something we alluded to in the very beginning. It's around cost. So we have a question here from Toby around ship owners are cost focused. System efficiency is a selling point, but CapEx is the crunch factor. Can the panel give their thoughts on and strategies on this going forward? So this whole CapEx heavy investment, the return on investment, we've also been through that, but we know that someone has to pay the bill, and then we also need to see the efficiency gain somewhere. So I think I might start with you, Jean-Charles, even though you're in on prototyping at the moment, financing needs to come from somewhere, right?
Yeah, but I think I will not share a price tag in that forum. I don't think it's appropriate, but I'd like to highlight one point. Obviously, wind power units are coming with a capex, but if you benchmark with other solutions available, and we can mention here the alternative fuels, green fuels, and carbon capture, and so on, those solutions are also coming with a capex increase, but also with an opex increase. I mean, I'm not coming back on the price of the fuels, on logistics chain transportation of liquefied CO2 if it comes to that level on board the vessel. And basically, we are the only solution that can actually reduce the emission and reduce the OPEX of the vessel. So I think I would encourage to look at wind propulsion from a total cost of ownership perspective, not only looking at the CapEx, but the complete lifetime of a vessel. And I'm pretty sure that having that approach, you will come to a conclusion that wind propulsion unit is cost effective compared to any solution available on the market.
I like it. So at least having the more holistic view on future fuel prices is quite relevant to have part of the calculation as well as the upcoming carbon taxes. For instance, the EU ETS also has a role to play here. Regardless, it is still quite a hefty capex investment compared to what else can be done. Yeah, Stine?
No, I just have a comment that I think is interesting to highlight here. It's quite modern to look at life cycle analysis and so on. And when we look at many of these wind-assisted propulsion systems, the concern from the ship owner is the remaining lifetime of the vessel. However, it should be remembered that the actual sales, and maybe I can get a confirmation later by the suppliers, can be used, taken off and reused, because they will likely have a longer lifetime than the vessel. So that should be considered also, that when you look at the business case and remaining lifetime.
Yeah, but let's hear that from. So we have Lauren on the call,
Yeah.
right? So taking sales off, reusing it. What's your view here?
Absolutely, that's part of our plan. So it's not needed for the business case. The business case stands up for a retrofit on its own, but the sails have a lifespan of 25 years or more. So absolutely, use them for a few years, then transfer them to your next vessel.
Interesting. Yeah, interesting. Then we also have a question from, and I've been getting a lot of questions in from the audience, which I think is really good. We have a bit from a manager perspective here. We have both a question around what will be the maintenance requirement, and is there going to be any constraints on the operation cost for the vessels? Let's start with you, Jukka, from Norsepower on that question.
Right. Definitely the operations and maintenance is an aspect to consider, not only for budgeting, but of course for training the crew and being able to go through the maintenance program, which we have a very sort of clear scheduled maintenance program, which I'd say 99% almost of tasks can be done by the crew after a relatively short training, which we give with each delivery project. And what we're also developing is training programs for crews, which we know will rotate more regularly or irregularly, but training is needed not only for the operations, but definitely safety aspect being very important in all operations. So that's.
And we'll jump back to this safety element as well. But let's stick with the maintenance for now. Cristina, I would love to hear same reflection from your side for Bound for Blue.
So I think that maintenance will vary system by system. So I can only speak about our technology. So in this case, if you look at the system, we've designed it so that it's very simple to work in an operational way, so that the crew can make the normal maintenance. So basically, if you look at the different parts, you would have the orientation system. So it's a slew bearing and an electric motor to adapt the sail orientation, at least to the best wind condition. Then you would have the flange deck connection also at the bottom that I was, so basically a standard bolted flange connection. You would have the main structure, which is made of steel, shipbuilding steel, so pretty easy for the crew to make maintenance on that side. You would have the suction fan, which has to be changed once every 15 years, 15 years. So basically, it's pretty easy. So it's the greasing to orientate the system, and the least movable parts don't have to be changed that often because the load of those systems is pretty small. So we've made it so that the operational costs, the maintenance costs, are very low, and that they're well known by the crew today, like greasing. And in case the owner does not want the crew to make that maintenance activities, then we also have an auto greasing system that can be added. So,
got it. Okay, thanks for those elements. Low maintenance cost and these full awareness. I think that's also what the audience here is asking for. Thanks a lot. Then we'll jump to the next question. There's a lot of questions coming. That's really, really good. This one is from Artem to all panelists. I'll pitch it in a minute. By building new toys, and I like that expression, new toys, on board the ships, you need to consider not only the save money introducing green technology, but you forgot about science around accommodation safety first. So safety first is definitely an expression in shipping, and the well-being and the safety of the crewfarers out there is definitely high on the agenda, if not highest. So please give your input about, for instance, bad weather conditions, heavy rolling, pitching, and how that affects the ship and the safety around that. I think let's start with you, Jean-Charles. What has been the considerations from Oceanbird in designing the first pilots here?
Yeah, I think it's a very valid question, and obviously we are all aware that the safety is coming first. And obviously, for us, we are going to get some limitation in terms of wind speeds and maybe on some type of vessel in terms of also platform motion of the vessel. And when we reach the limits, I will not enter into all kind of details, but we are going to tilt down on the deck and get back to a more neutral vessel, so to say. So very similar to what you are operating today. And with that said, that means also that we want to tilt down in any condition, and we have worked quite a lot on the safety philosophy and with all kind of redundant system and different procedure to be able to tilt down the wing in any condition. So that will be my short answer to that question. The safety needs and is very well understood and is on top of our agenda. And I think we are pretty confident that we are not going to increase the risk related to ships operation.
Thanks a lot and that's reassuring to hear for sure, Jean-Charles. Jukka, same reflections from your side and Norsepower?
Yeah, definitely. The design safety, of course, is what everything starts with, and it's required to comply with all the requirements of classification and the ship actual stability and such requirements. So the maximum loads, which we are very familiar with from experience as well, they will be applied in design to make sure that no foreseeable weather condition or operational condition will present any safety issues. And then, of course, the operational, the training aspect, which was just mentioned as well, so that the crew is aware what kind of equipment the ship is equipped with and how to operate it safely. The survival wind speed of Norsepower's rotor sail is 70 meters per second, 70. So we are confident that the ships entering any kind of storms will be very confident with the rotor sail on deck. So it's the strongest when actually standing on the deck. If a tilted version is installed, we recommend always to have it standing upright in heavy weather.
Okay, got it. Thanks a lot for that answer, Jukka. Then I'm going to jump to another question here on the chat as well, which I'm going to pass over to you, Lauren. It's an unknown LinkedIn user here. Also added to that, how much the wind systems installations are reliable in container vessels, where cargo operations and areas available is restricted. I think it's quite interesting. Now we talked about just call, if you have a vessel, to call us, and then we'll tell you whether it's applicable or not. And I've heard before that at least space restrictions on container vessels, but also obviously cargo operations. What are your reflections on that, Lauren?
Yeah, I mean, I think container vessels are more challenging than cargo and tanker vessels, for sure. They have bigger stability concerns, and the wings, to get the maximum efficiency out of them, you need to mount them above the containers. And so that makes it particularly challenging for retrofits, because the structure is not there. You would need extensive redesign of that structure. But I think it's certainly still an option for new builds where that can be integrated into the container structure to provide that support high enough and still maintain stability and have the wings mounted in an efficient and safe and secure way.
Yeah, thanks. Jean-Charles, also quite curious to hear your thoughts on the container vessel perspective.
Same statement, more challenge, but we should not get stuck in the challenge. And I think it has been publicly released that feeder container vessel 1000 TEU have been LOI or contracted a couple of months ago in Korea with actually wind propulsion, not wind assistance. It's not a technology which is represented on that forum, or superior which is represented on that forum, but it's also giving good signal that we can overtake any challenge and work on any type of vessel. Obviously, back on container, the retrofit will be somehow challenging.
Okay. I'm curious to know also from your perspective, Steen, and in terms of the interest that you see. I mean, in Njord, we work across all four segments, right? Container, bulk, gas, and tankers. So, I mean, do you see the same interest across, or how do you see the level of interest from the different owners that you work with?
I see good interest from tanker owners and bulk owners predominantly. Roll on, roll off as well have interest. We also work on a couple of vessels there. So on container vessels, we've been approached with the question, but it is challenging to retrofit wind assisted propulsion in container vessels, at least if you want a reasonable output from it. So it's not that I would put my money in other technologies for container vessels.
At least to begin with, until we get even more clever on wind here. Okay, thanks, Steen. Then let's jump to the next question here from the chat. This is a question coming through from Foivos to all panelists. Are those solutions as efficient in all wind directions, i.e. in upwind, downwind, sidewind? can these solutions be customized based on the routing of a specific vessel? You talked a bit about the collaboration, Jukka, on Napa here, so maybe the latter is less relevant, but at least your reflection on the first part in terms of all wind directions.
Right. Yes. So the polar diagram, I think Sten referred to that as well, being the description and definition of how the sail produces lift force with different wind speed and wind direction combinations. Headwind is never a suitable wind direction. I think that applies very well for any wind propulsion system. But as the wind shifts more to the beam, there starts to be higher lift, higher thrust available, and the most beneficial direction is beam winds. And then, of course, depending on technology, the direct the tailwinds are also beneficial, more or less. But I'd say beam winds are the most beneficial.
Okay, great. So let's jump to the suction sails then, Cristina, with the same question, bound for blue. How do you see that?
So I think it's important at least that the wind propulsion systems can deliver in upwind conditions. And in this case, it's because what you're seeing or what the sail is seeing is the apparent wind. So if you're going at high speeds, like maybe rotors, like the case of LDA, then all winds tend to concentrate on upwind conditions. So basically, either you do weather routing, which of course could be one of the solutions, or the solution has to be good at upwind conditions. So in our case, we're pretty good in all angles in this case and on average. So we don't have one that is much more suitable, like Jukka was mentioning, more these sides. In our case, we're good on average on those directions. The importance is the probability of occurrence of those winds. So basically, that's what you have to balance. So my system or the system you're choosing is suitable for some wind directions, and then looking at the probability of your wind directions if you're not going to put a weather routing on top.
Understood. Great. Thanks a lot. And then lastly, Lauren, same question for you on wind direction. What are your reflections here?
Yeah, I mean, it's been a real focus for us when developing our technology to make sure that we can perform in the widest range of wind directions. So the fact that we can adjust the cambered shape with the 3 elements and have full 360-degree rotation means that we're producing forward thrust in up to 10 degrees apparent wind. So really quite high up that headwind direction. But yeah, it's about optimizing the polar and the technology against your routes, and we've opened that window as wide as we can, and we get good performance across the range. So yeah, but there's for sure there are routes and technologies for every vessel out there that will be perfect for you.
Yes. Okay. Thanks a lot. Then we'll jump to another question here in the chat, because now we'll talk a bit about regulations. The question is minded for Norsepower, and Jukka, I'll give you the opportunity to start, but I'll also pass it around for the rest and maybe add on a bit here. The question reads to Norsepower: based on the installations done, have to get any chance to estimate the CII index, any improvements? So here, what is the impact on CII? But I also want to flip it a bit in terms of saying, what about impacts on EEXI as well? So Jukka, some reflections from your side on that?
Yeah, thank you. The indexes and regulatory pressures on ship owners, of course, are very much influencing also these decisions for which equipment, which type of efficiency improvements are applied. CII is quite simply the performance of fuel saving in that sense. So that can be very accurately already forecasted before the installation, and that's a routine that we do, of course, with the simulations. EEXI, of course, involves a lot of parameters from the ship, but the wind propulsion factor benefit is part of the formula. So also for that, the simulation results will be used when calculating the index value, and there will be an improvement on the ship's index depending on the configuration.
Thanks, Jukka. Jean-Charles, same reflections from your side in terms of regulatory impact for your solution?
Yeah, obviously it has a positive impact on both indexes and not mentioned, but also EDI when we talk about unveils. I will not spend too much time on that, but when we are talking with potential future customers, we are obviously highlighting the performance in the specific trade, and I have already mentioned that, but also in the quick screening, we can highlight the positive impact on the CI and the side. So that's what we give as an answer when people are coming to us. So I think, again, it was taking the chance to open the door and to get into a specific vessel study for which we are going to highlight this improvement. I think it's a technology which is scalable. So you at Njord like to talk about bundling, but I think it's scalable. We can see also several units on the retrofit. So we can say that relying on one technology, you can meet the medium-term or long-term environmental regulation requirements. So looking at wind propulsion, you can foresee the lifetime of your vessel, even for, let's say, recent new build or recently launched vessel.
Okay,
so
thank
it's
you.
important that also one tech can give quite good perspective in terms of lifetime and fulfilling the regulation in the long term.
Okay, thank you. Steen, I'm curious to hear from your side. Again, we've worked in Njord with more than now 60 owners and charters. I mean, how big, how much space in that discussion have you seen the regulatory part take space? What are the concerns and what are the questions from owners and charters around regulations, both CII, EEXI, and EU ETS for that matter?
It's a very broad answer I can come with, because it's every owner has a different perspective on how to meet the regulatory requirements regarding both CII and EEXI. Do they just want compliance, or do they have an element of, yeah, but that's in 3 years, we don't really have to do anything. But also some are looking very much at the EEXI to limit the impact of the engine power limitation. So where the wind propulsion can assist there is that you get an EEXI credit based on the global wind average and not based on the routing. So that can take off part of the pain on the EPL, and that has also been a business driver in some discussions. Mm-hmm. So it's a very broad, and what we do at Njord is we try to help guide the owner into the right combination of technologies to fulfill the business needs of that particular part.
Yeah, because I guess the tricky part here is then because your area of expertise is to combine a multitude of technologies, but then when you take technologies on and off, then the regulatory impact will see some changes accordingly, right?
Of course, and that is something that we manage for the client. And once we've done a proper solution design, we can add technologies, take them off, and immediately see the impact on CII and to some extent also the EEXI and EU ETS.
Yeah.
And I think we can also mention here the potential of the carbon credits doing wind installations as well. So there is good opportunities.
Yeah. Okay, thank you. So I can see that at least in terms of the questions, we're getting somewhat to the end of the pile. We've tried at least there are several that have the same theme, so we've tried to cover those as we went through. I have one last pre-prepared question for the 4 panelists here, which is about the future outlook. So we'll take a round for all 4 of you to answer the question in terms of, if we fast forward 5 years from now, what do we see in terms of adaptability or adoption of your specific technologies? What does the pipeline look like? And also, have you done or will you do any kind of iterations on the systems or the technologies themselves? We'll start with Lauren from Bar Technologies on that one.
Yeah, I mean, I think the future is really bright for wind propulsion across the different technologies, that the demand's there, the need's there, and the market's getting ready. I want to touch a little bit on what you said about ports, and I just want to say that the journey we've been on with different ports over the last couple of years has gone from them being very hesitant and nervous about our technology to literally welcoming us in and giving kind of flagship status and being proud to be a green port. I think that's indicative of the industry as a whole and the enthusiasm for it. So in terms of development of our technology, expect to see lots of 37-meter wings across retrofits, new builds. We're scaling up production. We're getting ready to go on this because the demand's there and the market's ready. And in terms of rolling across other vessels, we're also developing a smaller wing that will be even more suitable for the smaller vessel size down market. And yeah, ready for world domination.
Interesting. Looking forward to see that version as well. Cristina, Bound for Blue, same question for you.
So the market looks very promising. According to the IWSA, it's expected to double each year for the foreseeable future. So this means that as suppliers, we need to be prepared to supply all the systems that will be demanded. And at Bound for Blue, what we've done is to partner with the leading supplier of wind turbine towers, which is tier one supplier for Vestas or Siemens Gamesa. And with one of their manufacturing plants, which is in fact the manufacturing plant where we are building the units that I told you before, we would have a production capacity of 1,500 sails per year. So we're ready on that side. And with respect to the new iterations, at the company, the team really believes that it's throughout the innovation that we'll get the most out of it, and we won't leave potential profits on the table and emission savings untapped. So basically what we are doing is that we are really committed to improving our system in terms of aerodynamics, mechanical and structural aspects, and control mechanisms to always year by year move it a step forward. And in fact, last year, we announced a 20% improve in fuel savings by the aerodynamic improvements compared to the technology that we had developed previously. And we'll soon release new features of the fourth generation of the sail that will improve even higher savings and in terms of fuel and emissions.
Looking forward to see that. Thanks a lot for sharing, Cristina. Jukka, the future outlook from Norsepower's perspective?
Yes, definitely growth, strong growth. I mentioned already that during our first 10 years of operation, we've delivered 16 units, and the next year we will deliver 14 more. So now really the growth has started, and whether it's doubling each year or even more, of course, time will tell, but we believe that the demand will be stronger and stronger as confidence builds within customers for the systems that are available. I'm really happy to see that there are many different types of systems as well, because that they all provide benefits. So it's of course up to the customers then to find out the right one for themselves. We are developing our capacity in the first phase to be able to deliver 100 rotor sails during the next year and a half. So we're ramping up our assembly site, have developed our processes to be much more efficient and streamlined, more serial production oriented. Of course, our supplier base needs to be also prepared for that. So we have production hubs both in China and Europe. So we're able to deliver to various regions with also optimized logistic costs, which is an important part. R&D, naturally, a big emphasis also with Norsepower. So we're developing and learning together with our customers. I think that's a big part of our R&D is related to how the systems are operated on board, how the crew actually invents new ways to use them in a better way, which we have not, of course, by ourselves learned. We are not the ship operators. So there's many ways of improving the systems.
Okay, thanks a lot, Jukka. Impressive production line and expectations here. Thank you very much. And then Jean-Charles, last but not least, same question to you.
Yeah, a lot has been said already. It's always difficult to come to last. So I will try to bring a different angle to the same question. So you give us a 5 years timeline, and that's almost bringing us to 2030, right? We are almost in 24, and that will mean 2029. And I'm sure that people have been watching the outcome of MEPC 80 with the updated ambition from IMO. And we can read that the ambition is to have, sorry, I'm going to read because I'm quite bad at memorizing legal wording, but it's to have an uptake of zero or near zero greenhouse gas emission technologies, fuel and/or energy source, represent at least 5 striving to 10% of the all energy used by the shipping industry. So if we look at this number, so that means in 2030, we should have 5 to 10% of non-greenhouse gas emission fuels or energy source. And we have a different understanding of our industry, but I'm not sure that actually a green fuel will be available in that quantity in 2030. And I'm not sure that other sources have the same potential of wind. So to look at the question of the potential, I'm actually quite sure that it will become a market standard because there is no clear other option available for reaching the IMO ambition, and this ambition that will be further articulated into regulation. So yeah, so we better get ready for that, because as all other supplier, we expect a big boom. We expect that it's becoming a market standard on new build and also on the potential on retrofit. So we better start going to the drawing boards and engaging the discussion with as much as possible, because we need to get ready for that target.
Thank you very much, Jean-Charles. And a nice closure. I like the add-on into the future regulations as well. The IMO targets, highly relevant here in this discussion. That basically concludes the panel. We have been around quite a bit in terms of the number of questions coming across the different solutions here, and the more holistic perspective from Sten's sides. Some of the highlights that I've taken note of as we've gone through the panel here is that there's definitely growth to see, not only up until now, but also in the years to come. We've just been through that. There are also high savings to be achieved. We've heard figures like 10 to 15. We've heard up to 30% savings. We've heard in average 5 and between 5 and 25, all depending on weather routing and optimizing on that. We've heard numbers around return on investment down to 5 years, up to 10 years. So back to the CapEx investments, there are still tricks around how to navigate that CapEx investment between owners and charters, something that we work quite extensively with also in Njord to bridge that gap. We have a lot of different solutions. Today it's only 4 of the different providers represented today. There are more than 25 as we began, so the landscape is increasing. The future looks bright in terms of wind-assisted propulsion. I think that was your comment, Lauren, so very interesting. Safety is considered, and we acknowledge, and I think that was also quite clear from the audience, that safety needs to be considered, and that's also what I'm hearing from the different solutions. And then there is good practice and good sense in combining wind-assisted propulsion with other technologies out there today, something at least that we also spent quite some time on from our side in Njord. So some very good findings, very good insights across the board here. Thank you very much for providing those. This concludes the panel for now. You will be able to go into Njord's LinkedIn page to see the recording of today's session. That is also where you will be able to see the invitation, upcoming invitation for our next live event. So the next thing we will dive into is another, I would say, novel technology out there today where there's also a lot of questions on it, and there's also a lot of progress. That is air lubrication systems. So we will have a similar live event hosted by Njord, where we'll have the same format and go through the ins and outs of air lubrication, the applicability in shipping, and where we are on that. So stay tuned for that accordingly. We will be looking very much forward to host that. With that in mind, then I want to say thanks a lot to the different panelists for joining and for sharing all the variable insights, very relevant for us. And then thanks a lot for everyone who joined in. It was super good to see all the engagement, all the questions, and we look forward to see you the next time when we host our next live event. Goodbye for now, everybody.
Thank you.
Thank you.
Okay.